Look at this image. On the right, a computer tower handles digital data. On the left, a massive industrial robotic arm. These two machines represent the divide between digital logic and physical consequence. Currently, artificial intelligence exists primarily in the digital realm. It processes text, brainstorms marketing copy, and mimics human empathy through prompting frameworks. In this digital space, AI mistakes are low stakes. When an AI hallucinates a fake legal case or makes a data error, the fallout is typically limited to a PR headache. Developers respond by adjusting the context window, refining the prompt, and deploying a software patch to iterate on the error. This relies on a central comforting rule: software forgives. This cycle of trial and error has created an illusion of mastery. We assume that because we can guide a chatbot, we have solved the complexities of artificial intelligence. The stakes shift immediately when we move to embodied AI. Embodied AI refers to artificial intelligence integrated into physical hardware, like robots or autonomous vehicles. When you place that same intelligence inside massive industrial hardware, the rules of the cloud no longer apply. If a chatbot hallucinates, a company apologizes for a PR crisis. If a 500-kilogram robotic arm hallucinates a coordinate on a factory floor, the result is a fatal casualty. In the physical world, the safety net is gone. There is no software patch that can undo physical devastation. Safe AI advancement is currently stalled by a single bottleneck: physical translation. Most modern systems are built on an LLM. An LLM is a machine learning model trained to predict text based on massive datasets. This means the AI is trained on words, but it has never measured the physical world it is expected to navigate. This diagram shows the problem. The digital command is clear, but the system fails to account for the physical arc and the momentum of a heavy load. Because the algorithm lacks an understanding of mass, it cannot calculate the destructive force it is generating. This creates a dangerous gap between the raw force of industrial machines and the fragility of human tissue on an assembly line. You cannot prompt an algorithm to understand gravity or how material stress affects a mechanical joint. Pure software innovation has hit a wall because it lacks a grounding in physical reality. Silicon Valley's foundational philosophy is to fail fast and break things. Apply that philosophy to an environment handling live explosive shells. In this room, failing fast is a recipe for disaster. Hardware engineers do not have the luxury of beta testing their mistakes on the public. In the physical world, safety is not a metric to be optimized over time. It is a binary state. You are either perfectly safe or you are in critical danger. To progress, the industry must pivot away from merely processing text faster in the cloud. The next frontier is physics-informed AI. This involves algorithms where the laws of physics are embedded directly into the neural network. These systems calculate physical variables like inertia as instinctively as a chatbot predicts the next word in a sentence. This is the backbone of Industry 5.0. Industry 5.0 is a model of production where humans and machines work collaboratively. It is essential for everything from autonomous vehicles to precision bioprinting. Solving the physical translation bottleneck is the only way to integrate AI safely into human environments. Digital text and physical robotics operate in different environments, but they share the same objective: safe, seamless interaction between machines and people. This requires a shift in how we build. We must move beyond AI that simply talks and begin engineering AI that protects. We are entering a new era with one uncompromising law: code forgives, physics does not.